In 4.2, we're going to be looking at laws of exponents. So what you've seen in the worksheet or in the notes, I'm just going to demonstrate for you here. So here I'm multiplying two terms that have this same base. So they're two exponents. So this is x to the fourth, x to the third. The only time that you can follow this particular rule is when the base is the same. So what ends up happening is I have 2 times x to the fourth, that's 4 x's, times x cubed is 3 more x's. If you count these up, you have 7 x's. Taking a look at the next one, you have 3 times 4. There's your 1x from the 3x. And then you have 5 x's from the 4x to the fifth. 3 times 4, we know that to be 12. And then if we look at all these x's, we have 6 of them. That's x to the 6th power. So the rule is, when you have the same base, and you are multiplying powers, add the exponents. This is what we call the power of a power, or the power of a product. If I take a look at the first one, I have 2a squared and the whole thing is cubed. So I could write that as 2a squared times 2a squared times 2a squared. If I collect all my similar values, so we have 2 times 2 times 2 times a squared times a squared times a squared. 2 times 2 times 2 is 8. And then using the previous rule, a squared times a squared times a squared, we can add these three together, and we would get a to the 6th power. If I look at the next one, a b to the 4th, quantity squared. So that's a b to the 4th times a b to the 4th, which means a times b to the 4th times b to the 4th. And that gives me a squared b to the 8th. And then on this last one, m to the r power, quantity squared, I have m to the r times m to the r. Well, the rule says as long as my base is the same, I can add these two exponents. R plus r is 2r, so this becomes m to the power of 2r. So here's the rule. When you take the power of a product, apply the exponent to each factor, when you take the power of a power, multiply the exponents. What that means, if you look at this first problem, 2 to the 3rd power, 2 times 2 times 2. So you applied this exponent to the 2, and then you had a squared to the 3rd power. You multiplied 3 times 2, which is how you got a to the 6th. All right, so these last two examples sort of combine everything we've done. So we have c to the x power times c to the 5 minus x. So what we need to do is c to the x plus 5 minus x, right? Because they have the same base, so we just add x plus 5 minus x, and we end up with c to the 5th. On this next one, we need to distribute. You guys all know what distributing is. And then we'll use our power rules when we distribute. So we start with 6y squared times y squared. We shouldn't have to expand the whole thing. We know that y squared times y squared, we add our exponents, so we get 6y to the 4th. Then I distribute 6y squared times y. They have the same base. The exponent on y is 1. So 6y squared times y becomes 6y cubed. And then finally, 6y squared times negative 2. 6 times negative 2 is negative 12. And y squared stays the way that it is.